Okay, so what if, right, when we filled in our electronic structures, we don't have enough electrons to give all of the atoms noble gas structure? This is when we get to form multiple bonds, okay? So an example for this, we're going to use two different examples, NO3, and we're going to, or NO3 1 minus and N2, okay? So if I go through NO3 1 minus, right, first I would want to count my electrons. Nitrogen has 5 valence electrons, plus oxygen has 6. We're going to have to multiply it by 3, and then we've got one more for the negative charge. So that would be 18 plus 6, so 24 electrons. And then nitrogen, if we have nitrogen, that's 5 times 2. So that's going to be 10 valence electrons. So again, we start out by drawing our skeleton structure. So I'm going to put nitrogen in the middle because it's the first element listed. We'll put oxygen on, oxygen on, oxygen on. And then that removes 2, 4, 6 electrons. So I've got 18 electrons left. So I need to put 18 electrons on here. 2, 4, 6 for that oxygen. That oxygen now has a noble gas structure. It's happy. Now I'm down to 12 electrons. 2, 4, 6. That oxygen is happy, right? 6 lone pairs plus 1 single bond. So that's 8 valence electrons. It's got a noble gas structure. It's happy. Now I've got 6 electrons left. 2, 4, 6, 8, right? 2 there, 2, 4, 6. That's all of my electrons that I've got to put on here. Now I'm down to 0, but nitrogen is not happy, right? There are not enough electrons to give nitrogen a noble gas structure. So what it does is it says, hey, oxygen, I need some electrons. It's going to share those electrons. And so rather than having that there, right, what we're going to have is a double bond to one of the oxygens. Okay? So our structure then, right, would be nitrogen up to oxygen, out to oxygen, double bond to this oxygen over here. Okay? And again, this is an ion, so we would put it in brackets, and we would put the -1 charge on there. Okay? If it's like nitrogen, okay, nitrogen, we've got 10 electrons. I'm going to put a nitrogen on there, nitrogen on the other side. It has 1 there. Okay, well, I've got 8 electrons left. Let's give 2 and 2. If I do 2 there and 2 there, right, so two lone pairs, right, neither nitrogen is really happy. So what it's going to do is it's going to share those 2 there and then share those 2 there. And what we're going to have is a triple bond between nitrogen. Okay? If, however, we have the opposite problem, say we have the opposite problem and we have electrons that are left over at the end, what we're going to do is we're going to be able to then give an expanded octet. Okay? So this only happens if we're in period 3 or lower, okay? But our example for this would be like xenon tetrafluoride, okay? So xenon tetrafluoride, right? Xenon itself has 8 valence electrons, right? Plus fluorine has 7 times 4, so that equals 36 electrons. So if I put xenon in the middle, I'm going to put fluorine on, right, build my skeleton. Oops. If I build my skeleton, right, I've gotten 2, 4, 6, 8 that have been put on here. I've got 28 electrons to put on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I still have electrons left over, right? All of my fluorine have 6 lone pair electrons, and then 2 bonded electrons, they are all happy. They all have an octet. Xenon also has an octet, but it's got 2, 4, 6, 8 that are in bonded, but we still have 4 more electrons to put on. Xenon, however, is in the, let's see, 5th period, so it can have an expanded octet, right? It's really big, so fluorine really wants electrons. It forces xenon to share, so xenon will have 2 electrons, or 2 lone pair electrons that are going to be sitting on it, left over still, okay? So our expanded octet, right, it has to be in period 3 or lower for us to be able to do that, okay? The last piece with this is actually has to do with resonance forms, okay? Resonance forms are more than one structure, is when a compound has more than one structure that follows all of the rules, okay? So let's go back and look at our NO3 1-, right? We had nitrogen over here with a single bond to 2 different oxygens, and then a double bond to one of the oxygens, right? Currently, it's got a double bond to this oxygen over here. But is there any difference between that structure and having my double bond as the bond, or as the oxygen double bonded is at the top? There's no difference there, right? So really what the resonance forms are showing us is that there's no difference between these, so there's no energy difference between them. So this one is not any more correct than this one, okay? So the electrons are able to move around, and so we use this double-sided arrow to show that there are resonance forms that are all equivalent. Okay? And so really, this is not a correct picture of the NO3 1- ion. This one is not correct. This one is not correct. But a blend of all 3 is correct, right? So what that means is our nitrogen with each oxygen is really 1 1/3 bonds. If we were to look at it, we would expect the nitrogen-oxygen internuclear distance to not be similar to a single bond, not be equal to a double bond, but to be somewhere in between, okay? So again, we can move electrons, but as long as we follow the rules, then we may be able to find a resonance structure. If, however, we find that some of the atoms have a formal charge that is not 0, then we don't have a good resonance form, okay?